Hello, and welcome to another episode of Balanced Body Radio. I'm your host, Casey Ruff, and today we have another amazing guest to reintroduce you today. Travis Christofferson is a returning guest on our show. Be sure to check out his first appearance on episode 127 of Balanced Body Radio, which is one of our most downloaded of all time. Travis Christofferson has a degree in molecular biology and has a master's degree in material engineering and science. He is a full-time science writer and published the best-selling book, Tripping Over the Truth: How the Metabolic Theory of Cancer is Overturning One of Medicine's Most Entrenched Paradigms, which shows how the metabolic theory of cancer is overturning one of medicine's most entrenched paradigms. He is also the author of Ketones, The Fourth Fuel, Warburg to Krebs to Veitch, the 250-year journey to find the fountain of youth. He also wrote the book we'll be discussing today, Curable: How an Unlikely Group of Radical Innovators is Trying to Transform Our Healthcare System. He is the founder of the Foundation for Metabolic Cancer Therapies and the co-founder of Care Oncology. Travis Christofferson, what an honor it is to welcome you back to Balanced Body Radio.
Great to be back, Casey. Thanks for having me.
Absolutely. We had such a fun discussion last time, and it really was one of our most downloaded episodes. And we barely touched on the two books that we did talk about, and we definitely hardly even touched on your latest book. And so it's great to bring it back here and be able to discuss that with you today. As we were kind of talking offline a little bit, we were kind of going back and forth on what we should talk about and what you wanted to talk about. And you said specifically, we can always talk about ketones. Ketones is one of my favorite topics. And I think they're mine too. How did you become so interested in ketones to begin with?
Oh man, that goes back to Tripping Over the Truth when I was researching this sort of non-standard cancer theory, the metabolic theory of cancer. And the low-hanging fruit of therapeutics was obviously a switch away from glucose metabolism to ketone metabolism. So that was 2014. And I just started reading, the literature, the publications on the ketogenic diet. And there was not nearly as much then as there is now. If you look at a Google trend search of ketones, it just exploded around that time. So people became very interested in it, but it showed such incredible therapeutic potential for just a wide, almost inconceivable amount of maladies, from traumatic brain injury to Parkinson's, all neurodegeneration, and obviously cancer. So it was just a dive into those publications, and then realizing that it had this malign history of being the sort of pathological state. And then sort of around the 70s began viewed as a sort of elegant adaptation to starvation. And now it's really exploded into not only therapies, but just potentially for optimizing health and so forth. But yeah, just absolutely fascinating biochemistry. The scientific story behind it's fascinating because of the characters involved in the science were such compelling people. Yeah. So yeah, it's still an ongoing fascination. There's still, a lot of research to be done.
That's amazing. You are so good in all of your books at weaving together the science and the biology with those stories. You're like the best history teacher that I never had. Like, you're really good at exploring the context and the situations, and all the work of Otto Warburg is amazing, but under a certain context is even more rich and dynamic. You do such a good job telling those stories. I really can appreciate that. For somebody who hears ketone and they think, oh yeah, I know what that is. I saw a magazine cover at the grocery store, and I think I'm supposed to eat a bunch of butter and, chug the butter in my coffee and maybe eat lots of bacon. Can you explain the difference between what most people may think of when they hear keto versus what the actual molecule is, how it originates in the body, and some of the things that it does?
Yeah. So the way I think of the ketogenic diet is sort of the nutritional maintenance of the fasting state. And the way ketones were first discovered is when a person just doesn't eat for a period of time, their body really has no choice but to start mobilizing fat and generating ketones as a source to replace glucose, because you burn through carbohydrates in about 24, 36 hours, and then there's none left in store. So your body's faced with this crisis. And when it mobilizes fat, it begins this sort of biochemical process of burning it called beta oxidation. To do that, it cleaves off two carbon chunks to acetyl-CoA. That enters the cell, and then there's a huge spillover effect of that as acetyl-CoA, and so there's enzymes waiting to convert that to what we call ketone bodies in the liver, and then those are exported in the circulation to replace glucose, especially for the brain, which can burn up to 2/3 of ketones when you're in this fasted state. So it's really, it's a replacement for when you don't have food. The ketogenic diet just sort of is a hack to maintain that fasted state. So you just drop carbohydrates down to a very low level, and you up your fat, and then you stay in that, kind of the fasted state. Whether that's natural, you have to go back through evolutionary history and really be able to pin down what people ate to know if a ketogenic diet is a natural diet that we sort of evolved eating or not. But certainly we evolved to not eat for periods of time. So all that still has to be sorted out. Whether maintaining a ketogenic diet for a healthy person over a long period of time is a good idea, or should you cycle? Those sorts of questions need to be worked out.
Sure. Yeah, but the idea that humans can go longer than a few days without glucose is such a foreign concept, or at least it was for a long time. You mentioned the studies, and we talked about this last time. Are we still referring to some of those Cahill studies where he did the 40-day fasting and showed where the different fuel sources were coming from and how different parts of the body were utilizing them?
Cahill was a pioneer. He was the one that looked at this first through the lens of a adaptation that was beneficial to humans, not as a pathological state. And when he did the math on carbohydrate metabolism, nobody could figure out how a human could not eat for 30 days. So a normal weight person can go, easily 30 days without eating, as long as they have water. And the math didn't work out because you burn through blood glucose too fast. At that time, it was thought that the brain could only use glucose. And so he was the first one to show that the brain switched over to this sort of, it had this hybrid capacity to switch over to ketone bodies. And that solved the dilemma of how can a person go so long without eating. The longest fast ever was a guy, he went, I think, a year and 11 days. He had plenty of fuel to start with. I think he weighed 400 pounds when he started, but he was fine. They gave him some electrolytes and supplements, but he was fine for over a year without food.
Wow, that's incredible. I can say just anecdotally, I had a client once that would do extended fast during the week. He would have his last meal on Sunday, and then he literally would just have coffee in the mornings and wouldn't eat again until Friday. And I trained him on Tuesdays and Fridays, and he would come into the gym hungry on Tuesday. He would not be hungry on Friday. And dude, I kid you not, he would PR deadlifts on Friday. He felt great. You wouldn't think that would be possible. It's incredible.
Yeah, it's interesting. My son, he's a sprint athlete. Deadlift, same thing. So he's a push athlete for the USA bobsled team. And these guys are, if you're going to go to the far end of the spectrum of athletes, they're the dragsters. They are just designed to sprint for 15, 30 meters as fast as you can, carrying a load. And in a fasted state, there's plenty of blood glucose there to maintain. And if you're taking creatine and you have enough phosphate energy, you can explode like that. So it's not a detriment I don't think it's a detriment at all to those sort of sprint activities.
Yeah, that's awesome. I also know somebody in England who just completed some 5 days of cycling where they were doing like at least 100K every single day. And they did the whole thing fasted. And I know they documented a lot of their health metrics and numbers. And just, you're right, like sprinting, you wouldn't even think you could be able to do that, sprinting with no, quote unquote fuel. I just think we so much underappreciate what our bodies can do with so little inputs. It can just kind of sort things out itself.
Yeah, we're incredibly adaptive. Yeah, that's a good and tweakable. It's always amazing to me, like even taking certain supplements or things like that, you can dramatically change just the physiology and biochemistry that's going on in the body. And it's got an amazing recovery capacity, bounce back from insults. It's we don't give it enough credit. It's an incredible machine.
Yeah, I totally agree. One of the cool things from the Cahill studies that I really didn't appreciate at first was the gluconeogenesis that happens in the body. I think that most people would think like, okay, I don't have carbohydrate fuel, so I need it from somewhere. So now I'm going to ramp up my gluconeogenesis. My body is just going to start removing muscle tissue like gangbusters to turn it into sugar. But the thing I didn't appreciate was as your body is reducing its need for sugar, the need of gluconeogenesis reduces so low that it can get it from other sources besides muscle. You can absolutely maintain muscle mass in an extended fast just fine.
Oh, yeah. Ketones are, they always say muscle sparing, which I think is sort of it's a funny thing to say because glucose is muscle sparing, right? Anything you can burn beyond protein is muscle sparing. But the way your body patchworks together the metabolism to replace blood glucose when you don't have carbs, there's all kinds of pathways. It's not just gluconeogenesis. For example, a bear that hibernates, right? They don't need as much glucose because their brains are not as big. Humans are special because we have this huge metabolic sink, our brains. It costs us 20% of our basal metabolism. So it's a big problem for us when we don't eat. But what bears can do is just by burning the fat they've stored, when it comes at triglycerides, you cleave off the glycerol molecule, 3-carbon. They can use that glycerol to make glucose. So they never even need to use protein for gluconeogenesis to replace glucose. We do that. We do all sorts of alternative pathways to replace the blood glucose. So it's not necessarily just the gluconeogenesis from protein that's feeding it.
Such a great point. That's fascinating. Yeah. We've already mentioned cancer. We talked quite a bit about cancer last time, but just to reiterate, how beneficial are ketones in the cancer treatment world, and what have we learned even more recently about that?
It's still an ongoing thing, Casey. And what's frustrating is the clinical trials are so hard to do because there's no money to be made. There's no patentable drug, so you got to rely on foundations or when the NIH is feeling sort of philanthropic. But it's when you look at what happens. So cancer cell has an insatiable appetite for glucose. We know that. That's what a PET scan is. A PET scan is radiolabeled glucose, and you can visualize tumors that way. You inject somebody with radiolabeled glucose, and the tumor cells preferentially take it up and trap it in the cell. So the idea behind the ketogenic diet is you bring down blood glucose, you replace it with a ketone body, which has to be burned in the mitochondria. And we know that cancer cells have impaired mitochondrial function. Whether it's intentional by the cancer cell or it's damaged, that's still an ongoing debate. But we know that they don't like to burn ketones as much. So what you get is this rarely happens in pharmacology, this beautiful therapeutic differential where healthy cells have switched over to burning ketones, which causes them to go into this regenerative, reparative state. They become very robust to insult, right? And then the cancer cells are struggling because they're not getting enough energy to fuel all their growth, and especially to mop up free radicals. They're always on this very precarious edge of dying from oxidative stress. And that's what radiation and chemo is. It's oxidative stress. So you set them up. You set up the cancer cells to die easier and healthy cells to go through insult more. So when you have somebody in that state and then you give them chemotherapy or radiation, you see a more dramatic effect. You see a more therapeutic effect, but you also see a huge reduction in side effects. So when someone's on chemo, you can measure the number of times they vomit. That can go from 7 a day, literally, to 0 when someone's in a fasted ketogenic state. Hair growth, mouth sores, all the things you can count go down, and the subjective things like fatigue and things like that. So I think that's where it's got a real potential. Is just, I envision in the future there'll be 3 branches of oncology. There'll be radiation, medical oncology, which is chemo and drugs, and metabolic. And so you'll have somebody put people in this state before they get standard of care. And it's moving in that direction. They're noticing all kinds of drugs work better on the ketogenic diet, at major cancer institutions. We're trying to fund a trial, the ketogenic diet on glioblastoma, alongside standard of care at Cedars-Sinai. So I think within, if you have me on again in 5 years, I think it'll be a much different landscape.
I really hope so. I really hope so. Yeah, I mean, in Curable, which we're going to talk about here in a second, but in Curable, you make the case that we're diagnosing more cancer now, but we're not changing the survival rates. What is going on with that? And I asked you this question. I love asking people who do the research this question. What would you do? If somebody gave you the diagnosis, knowing everything you know, what would you do? And most of us can sit around and we can theorize what we might do, but we don't actually maybe know what we would choose in that state. We've hosted Martha Tettenborn on our show, who was given a cancer diagnosis, and she was a registered nurse, and she did the research herself. And so she learned that if she was on mostly very strict keto during the procedure, and then when they traveled to, I want to say Toronto, to get the treatments done, she would do 48 hours fasted before the treatment, 24 hours after, full fast. She was a little tired. She never got sick. She was fully functional. She made all her meals. Talk about somebody who really had to put their money where their mouth was, and she did great. And now she's sharing that message along, so many other people that are trying this themselves. That nobody's talking about this because nobody's going to make money on a trial. but you can do this easily for free. And whether it's going to, work with cancer and you don't have to do other treatments, it's kind of controversial, but at least it will be helpful.
Right. Yeah. Yeah. I would do a number of those things. And I always have to preface that with, every case is individual. So if somebody wanted to fast before chemo, they would need to have a medical workup, because if they're late stages of cachexia, they may not be able to lose weight and may be detrimental. So always work with other people. But yeah, for me, when you look at medicine, it's always done through the lens of risk reward. So I look at a ketogenic diet as extraordinarily low risk, and that's already been proven. It's very safe in a cancer setting and with health people that are, in a decent functional state. And so why not? Why wouldn't you do that? I would look at all, the repurposed drugs that we know are safe, that have anti-cancer activity, combinations of those. There's some nutraceuticals that have incredible early data, like luteolin, apigenin, those kind of things. So I couldn't imagine, I think doctors probably do, when it happens to them, way more than they would recommend to patients under most settings. So I look at from that end of risk reward, I would just do all the combinations of all those things I could. Yeah, why not? It also, when you think of the cancer problem, it always leads you to, well, how do you not get cancer in the first place, right? How do you prevent it from happening? And that's where I think a ketogenic diet could, or intermittent fasting, whatever, is proven to work, could have a huge role to play. Because one of the most astounding aspects of being in ketosis is you get this dramatic ability to antioxidant effect. So you get an upregulation of all these enzymes that quench free radicals like superoxide dismutase, catalase, but you also get this huge increase in glutathione, the ability of glutathione to mop up free radicals. Free radicals, we know, break DNA. DNA can trigger cancer, usually it's not the genetic mutation itself. It can be, it's a combination of mutations, but that triggers a whole series of other epigenetic things that can lead to cancer. And ketosis prevents free radicals, which prevents DNA breaks. So that may be one way to just not get cancer in the first, or at least reduce the probability of getting cancer in the first place.
Sure, or make it move slower so that maybe you do have cancer, but it's not going to advance before you're going to pass away of natural causes anyway. It's so interesting. Yeah. There's just so many benefits on so many levels. It's like, we look at it as like you're going to go on the ketogenic diet or being ketosis, but it really seems more like, no, we have a real lack of ketosis in our natural lives because of all the crap that we've set up for ourselves.
Yeah, I couldn't agree. That line in the New York Times article that Gary Taubes wrote, I think in 2004, 2006, maybe, Richard Veach was quoted as saying, the natural state of mankind is to starve occasionally. And that's a huge question. Have we stepped that far out of our natural physiology that we're way more sickly than we should be, right? Should we have cancer rates like this? Because we don't see those in the wild with animals. So we've stepped out of this biological niche that is conducive to good health into this new era. That probably happened about 12,000 years ago with modern agriculture, when we just drastically shifted our diet. And then became very indolent, desk jobs. We solved energy problems. We didn't have to chop wood anymore. So it's a sort of collision of lifestyle events that led us to this, what I would call an unnatural state. And yeah, I think when you look at the benefits of ketosis so far in the literature, from neurodegeneration to diabetes to, you just go down to almost every chronic disease, right? That's the biggest burden in the healthcare system. So yeah, it begs the question is, how can something be that beneficial if it's not something that's evolutionary baked in to be this therapeutic effect?
Yeah. Great point. It's so ironic that technology is what makes us human. Banging two rocks together to make a tool makes us human, yet that same technology comes back to bite us in the ass, 12,000 years ago with agriculture and everything.
Solve one problem and create another.
That's right.
We're good at that.
We're good at that, and selling it to you, making some money off of it, which is a great segue into Curable. What an amazing book. I've really enjoyed listening to it. Let's talk about you writing the book and how you came to this idea. But first of all, can you explain what a crappy baseball team from 20 years ago has to do with Berkshire Hathaway, has to do with our medical system?
I wish I would have shortened that intro a little bit because I was making too many points at once. But yeah, the Oakland A's, it's funny because my dad's business partner for 20 years was the second baseman for the Oakland A's when they won those 3 World Series. Dick
No
Green, he
way.
was, yeah,
Wow.
the Reggie Jackson, they won in the early 70s, won 3 World Series in a row. So I always liked the Oakland A's, but then the movie Moneyball came out, and it just a perfect example. I would say the book really is about, when you look at a chart, there's a really just eye-popping graph on the World in Data website where it shows the life expectancy of like 15 developed countries, so European countries and us and Australia, all what we call developed advanced economies. And we are dead last in lifespan and spend by far more than anybody per capita in healthcare. So the question is, okay, from that chart, what are we doing wrong? We're doing something drastically wrong. And then the segue to that is, well, medicine was always practiced under this ethos of autonomy. Physician instinct was always the coveted thing. And there's a quote by Hippocrates that a physician's instinct matters more than any external measurement. And that ethos is carried on till today, where we count on doctors to be these sort of sovereign islands of making these incredibly hard decisions under clouds of uncertainty. And we just do not use data like we should in healthcare. And so the Oakland A's were a perfect example of that. They have an extraordinarily low budget, like 3 times lower than the New York Yankees. They're at the bottom of the list, but somehow they win all the time. And the way they do it is they sidestep all the human biases that come with picking players. So most teams will use talent scouts, and they'll pick players based on flawed instinct, right? If you cut through that with data, you can find these mispriced gem players that don't look, talent scouts hate. They might be, short, just not look like athletes or whatever, but the data screams that they're good baseball players. So yeah, when Billy Beane took over and started using data to pick players, every player that ran out was based on a mathematical formula, right? And they just were incredibly good for their budget. And that's a model for what we could do for healthcare if we did it right, is just start using data way better and relying less on human instinct.
Yeah, you have another sports reference, Jeremy Lin, which I think was a really good thing that people will probably remember. Linsanity, like 10 years ago. Yeah. Who is this guy? Where did he come from? He doesn't exactly fit the mold of what you would expect, but what an amazing basketball player. And people knew, if you knew the math, if you knew the stats, he could have been plugged in way earlier.
Yeah, completely. Yeah, the bias they had against him was they just didn't consider Asian American players. They'd never seen great Asian American players, so the talent scouts passed him up over and over. And then they did athletic tests, and he was incredibly athletic, explosive, acceleration, vertical jump, everything. But he just had this intangible quality of passing and making his team better that you really can't instinctually see. But the data, was able to uncover that. And finally, I think it was the Houston Rockets. They adopted a Moneyball like sort of methodology to picking players, and I think they actually passed him up. But even though the data said it was great, they still let their biases, take over and passed over him. And yeah, then he went on to Linsanity, and he was incredible.
Wow. Yeah, that's such a good point. I'm glad you included that in the book. Those days were really fun. It was fun to follow him back then. Does he even still play? I don't even know.
I don't know if he does or not. That's a good question.
Yeah, funny. Well, that leads us to the question, like, how good are we at making decisions?
Well, yeah, that goes back to, all the sort of foundation of most social sciences that we're good at it, right? Economics, psychology forever thought that humans were rational creatures and usually made rational decisions. But then these two Israeli psychologists came along, and like, that just doesn't ring true to us. So they started really studying it. And they just, in situation after situation, they were able to prove how flawed our thinking is. Like, for example, they would use college students. They were both professors, and they would ask their class of, say, 100 college students the price of something they didn't know. For example, wine. No one had a clue what this bottle of wine should cost. But before they had them guess what the price should be, they had them write down the 2 the last digits of their social security number. The group of students that had higher digits, last two digits, invariably answered with a higher number. So that's called the, what is that one called? That's called the anchoring bias. So once you anchor your thinking to a higher number, in this case, your subsequent decisions are biased by that anchor. And just one example of that after the other, where our logic is just incredibly flawed in our thinking. And a good example in the healthcare field with that is in the 1980s, there was two treatments for lung cancer. There was surgery and radiation. And surgery came with a much better survival rate. But if the doctor said, okay, surgery has a better survival rate, but it comes with a 10% chance of death, only about 50% of the people chose surgery over radiation. If the doctor said surgery has a better survival rate, but it comes with a 90% chance of survival, then 80% of the patients chose surgery. So it's a pure, that situation, life and death, should be purely, completely objective and statistical, but just based on that framing, how the doctor framed it, people would make wildly different decisions.
That part really surprised me. I couldn't believe the difference in those two things. You just said exactly the same thing, but worded it differently, put it in a different perspective. And the numbers that you see, it's so vast. Did that surprise you as well?
Oh, it's crazy. Yeah. And that goes to what you were talking about earlier, that we were much better at diagnosing cancer, right? And so for example, thyroid cancer, we're way better at diagnosing it, but the death rates haven't changed. So what happens is you will now tell somebody that they might have cancer, and you'll use that word. Now they're terrified. And if you have cancer, you want to treat it. So they will demand treatment. There's a lot of cases where these cancers are benign, slow growing. They don't represent a real health, mortality risk at that point. But once you say that word cancer, you put people in this state of mind where they almost demand treatment. So we horribly overtreat now with chemotherapy, surgery, radiation, just because the way it's framed. And so it's incredibly complex, but you need to somehow train doctors to walk that back. And that just represents how hard the problem is.
Sure. Is this also a result of our diagnostic tools getting so much better? We're able to pick up trace amounts of things that we wouldn't have bothered with in the past. Is that part of it?
Yeah. More people get screening, and we're better at screening. And this new age of blood biopsies is coming along, where you take a simple blood draw and they'll be able to tell you with some probability whether you have cancer or not. Which that opens up a whole question of will this be a net benefit to society? Because you're going to be telling people they have cancer, when in some case you're going to get false positives no matter what. That's just the nature of any test. So that remains to be worked out. But yeah, the diagnostics is getting incredibly good.
Yeah. Is prostate cancer another good example of a slow moving cancer for most people that's like, yeah, we could maybe do an operation at age 70, or we'll be better off just letting it ride?
Yeah, completely. Yeah. Prostate cancer, like you probably remember in the book, Charlie Munger, he just marks off the PSA. He's 90, I think he's 98. His doctor tries to test for prostate specific antigen, PSA, every time he goes in, but he just crosses it off. He says, "Why do you do that, Charlie?" He goes, "Because I don't want to give you the opportunity to do anything dumb." Because right, most men will have some degree of prostate cancer when they're older, but it probably won't kill them. So now you open the door of, if you suspect it's there, surgeons may want to operate. They may want to give drugs. And prostate cancer is a perfect example. There's 5 treatments for prostate cancer. There's watch and wait, based on a PSA diagnosis, watch and wait, surgery, and then 3 different forms of radiation, from the cheapest form, a middle range form, to the highest form, which is proton beam therapy, which is, I think, about $120,000.
Wow.
The problem is not one of those 5 therapies has been proven to be better than the other. So watch and wait costs about maybe $2,000, and just sort of advanced surveillance, checking more, where the proton beam is $120,000. And you look at the data and you can see which one's getting prescribed more and more. It's the most expensive one.
Wow.
So that's another flaw in the system, is we incentivize doctors through the fee for service to charge more, right? So you get this over treatment problem.
Wow. And it's such a systemic issue. I was so surprised also to hear the numbers of, similar demographics, different hospital systems. You would think, maybe incentivized by the same thing, and they probably are, but it's a systemic issue where if you're in one system, like you might be more entrepreneurial minded and you might be pushing those things a little bit more so you can make more money, where other people might just think they're doing the very best thing. It would be so hard to be, totally entrenched in whatever everybody else is doing around you.
The variation in treatment is frightening. So you can measure that very well. It's just how different doctors treat the same ailment. So, for example, you can drive, there's 2 towns in Ohio, one Cincinnati and then some smaller towns 50 miles away. You're 2 times more likely to get a stent put in that small town for the same diagnosis. There's a 15-fold difference in back surgeries between different counties in Washington. Some doctors in the primary care setting will order 2 times the amount of MRIs as another doctor in the same clinic. So the variation in treatment is crazy. And that just means that it's a zero-sum game. There's one right answer in each medical thing, and you're just not getting the right answer a lot of the time, the right procedure. And it goes, the extreme example that was Redding, California, where there was a heart institute where they were just operating on everybody that walked through the door. If you showed any minuscule, even hint of blockage, they would put you on the operating table. And so the regulators finally, it was a self-perpetuating thing because their statistical data went up because they're operating on healthier and healthier people, right? Healthy 40-year-olds were getting an operation. So their mortality data looked good because nobody was dying. They're operating on healthy people most of the time. And so they thought they were doing the right thing. And when the regulators came in, they just put the hammer down. They thought it was just purely a money grab. These guys were doing this just to capture money. But then the reporters came in and they realized these guys genuinely thought they were doing the right thing. One of the staff there flew his mom in from Chicago to have her operated on. That's how, they were just fervently believed they were doing the right thing. So yeah, you get this psychological ratcheting effect peer to peer where it can just go really, really bad, really wrong.
Sure. And to me, that goes back to the decision-making process. And you think like, okay, I'm sitting in front of a doctor. He went to school for 8 years, really smart guy. He's going to be able to make the right decision. Can you maybe explain some of the complexities that these doctors have to deal with, even just in the number of prescriptions they can write?
Oh, doc. And that's the problem is we count on them. We sort of, we put them on this pedestal that they're going to make the right decision, but their job is just destined to fail in that situation because medicine is just too complex. Most of it is operating in uncertain situations all the time. It was always tradition, very thin evidence to surgically remove kidneys for advanced kidney cancer. Then they finally did the trial and showed that there was no benefit to that over the chemotherapy alone, but they were doing both and just based on more tradition than anything. So those are the studies we need to remove that uncertainty for doctors. So we need just a better marriage between the ability to capture that data, to do those trials, to provide those guardrails for doctors, to make better clinical decisions. And that doesn't mean you have to get rid of the intuition doctors have, because that can be magical too. There's many cases where doctors, just based on intuition and years of experience, have done incredible things. So you don't want to remove that, but you want to provide these guardrails to sort of, keep them from these incredibly hard decisions, to keep them sort of guided down the right path.
Yeah, you and I were talking a little bit offline, and it kind of reminds me of the airline industry and like how many billions of people fly all over the world without anything happen, like magically 550 miles an hour at 35,000 feet, and they don't die. They ever like planes don't crash very often, and it's remarkable. And even when things go wrong, pilots can make really good decisions when it comes down to it. But and they still have that creativity to be able to do that. But you're mentioning guardrails. Like there's so many guardrails and checklists and all these things that you have to do to be able to put that chunk of metal in the air carrying 200 people. Like, why can't it be more like that?
Yeah. when I mow my lawn, I'm very aware that my motor can stop at any minute, just quit running. I always think of that when I'm on an airplane. How does this thing just never? How does it always work?
Totally.
And you said checklists, and that's, the airline industry has gotten so good. Whenever there's a problem, they build in a redundant safety system. So they've just checked off anything that can go wrong over the decades to this point of almost perfection. And we did that. I can't remember the year, but they did that. They did a clinical trial where they instituted surgical checklists, right? Just to eliminate human error. Make sure you give the antibiotics before surgery. Make sure, and you have to check it off to eliminate the doctors from forgetting. The mortality rates dropped by 40%. So without those, those checklists, those things that govern our ability, because we're going to make mistakes, the things that govern those, without those there, you're just going to continue to have those sorts of problems. And we don't do that well at all in medicine.
Wow, that's absolutely crazy. We talked a little bit about patentable drugs. I thought this was fascinating, and I knew that there were certain things that would happen if you wanted to patent a drug, and how the pharmaceuticals have those, 10 or 15 years that they can make a ton of money before they lose the patent, and basically anybody can copy it, and the pills prescription can become generic. Can you talk a little bit about that and what issues arise from that problem?
Yeah. So that's. You're right. So that's the process, right? We go through all these phase 1, phase 2, phase 3. It takes decades, billions of dollars sometimes. And then the FDA will approve a drug for that indication. So let's use metformin as an example. It went through that process, got approved for type 2 diabetes. Now what happens is now it's prescribed throughout the population in mass. So you get decades of clinical data of it being prescribed in this disease population. Now you can discover new things. Like, it was noticed that there's huge reductions in cancer rates with type 2 diabetics that are taking metformin. So you'll notice other things, other diseases that would potentially be good that it has reductions in while it's being prescribed. But now, because it's become a generic, there's no incentive for the pharmaceutical company to win an indication for that new disease. So what you do is you leave a lot of pharmacological potential on the table because of that. They're sort of stranded in this financial purgatory. And that's this idea of repurposing drugs, right? And metformin is really interesting because it looks a lot like the ketogenic diet. You see reductions in all kinds of diseases when people are on metformin. And there's no incentive to study it. But what we look at metformin pharmacologically, what it looks like it's doing is really targeting the aging process. It's slowing aging down. So you just get this reduction in chronic disease in general. And they've been trying to do a trial called the TAME trial, targeting aging with metformin, for a long time. And the NIH finally agreed to classify. They couldn't kick it off because the NIH wouldn't consider aging a disease, and drugs are for diseases, right? Not aging. So they finally reclassified it. They got the funding, but then COVID stopped it, but it should start back up. So how amazing would it be? It's about a few pennies a pill. It's extraordinarily safe. If you could give this to people in their 60s, slow down aging, reduce the probability of all kinds of chronic disease. But those kind of things just sort of get lost by the wayside. We have this weird sort of methodology where we try to treat disease once it's become entrenched in the body, instead of really, really considering how do we prevent it. And that's been the overwhelming imperative behind pharmaceutical companies for as long as they've been around.
Perfect example is type 2 diabetes. Let's let you have controlled glucose while your insulin is going bananas for 20 years, 30 years, 40 years. And then only when your glucose starts to rise, oh, well, maybe this is a problem. We should start to deal with this. Like, this has been a problem for decades.
Yeah. Have you ever talked to Benjamin Bickman? Have you had him on your show?
Absolutely. Yeah.
Absolutely. That to me is one of the most just crazy points in the world. Ben's big sort of push is that we don't characterize type 2 diabetes the right way. So you just said it perfectly, because insulin's rising for decades before glucose does. Why don't we start targeting those people? And there's all kinds of things you can, like ketogenic diet, a low carb diet. That's how you can target it at that point. But there's no emphasis on that whatsoever. You just wait till they're actually sick, and then we start giving them drugs and don't tell them what to eat. That's one of the most black and white, obviously flawed ways that healthcare has treated a disease.
Yeah, absolutely crazy. And it does come down to money. So I want to ask you just your opinion. Do you fault the big pharma for some of these issues? It doesn't really seem like it's really their fault. If they can't make money on some of these trials, that's just kind of the system we have. Is it their responsibility?
I don't fault anybody. Yeah, they're just doing what they can do within the confines, right? Of course, there's nefarious players. There's nefarious people in every industry, right? But they're incentivized to make incremental improvements on things they know that can work. So like in the cancer setting, when a drug gets approved, sometimes it might confer 1 month of survival. You might be sick that whole month, but that's what all you get. So yeah, they're incentivized to not like swing for the fences and do things that can really matter. And then, you've got this problem of them sinking $1 billion into a drug and they have to recoup it. So the prices are just crazily high. It's not, I don't know how you fix that until you can incentivize people to care about prevention. And there's some decent examples of that where in a primary care setting, typically it's fee for service. So you're getting paid to treat sick people, right? The more sick people, the higher you're going to get paid. What they're doing is they're giving doctors a bolus of money per patient, and they get to keep that money if their patient stays well. So now you've completely turned their incentive structure 180 degrees. Now these doctors are focused on diet, on telling people how to stay healthy and really trying to do that instead of just waiting till they get sick and then making their money.
Yeah, that's a really good thought. Just with some of these low cost options, so we have intermittent fasting or ketogenic diet or repurposing drugs we already know a lot about, and it's just about like collecting data and testing it in different ways to see if it can be multi-purpose. All of that sounds really smart. We know that the supplement market for probiotics has gone through the roof in the last few years. You seem to have a favorite probiotic that's even less expensive than that. Can you tell us your exploration in low cost probiotic treatment in the form of fecal transfers?
That was a good segue to that.
Yeah.
That was when I looked at the health. The biggest problems that seem in the healthcare system were what we talked about: overtreatment. That's very easy to measure, and then variation in treatment. And then the other one are these low-hanging fruit things like the checklist we talked about. Hand washing has always been a problem. How do you get doctors wash hands? When you get them to wash their hands regularly, you see a huge drop in infection rates. And that was one example of this low-hanging fruit that got dismissed for so long. And what you're talking about is a fecal transplant. So there's a problem where people get hospital-acquired infections, typically called C. diff, Clostridium difficile, and it's a horrible, horrible disease. It goes into the colon and just if you can't get rid of it, you just slowly get sicker and sicker until you die. And typically antibiotics work about 75% of the time, the first round of antibiotics. And if you don't clear it at that time, the second round you have less of a hope of it clearing, the third round even less. So it's a terrible sort of spiral downhill. It was back in the 50s, there was a doctor in Denver that just had, and this is back to this intuition, he had a sort of an insightful moment where he's like, well, he had some patients that after the antibiotics from surgery were getting, C. diff. And he called it, well, what if we could restore the balance of nature? What he meant was restore the probiotic ecosystem in the colon. So he had some nurses go to the maternity ward and collect some feces from, I think it was from pregnant women, because he thought, they're screened and they're healthy. And then he just did an enema with that into the patients, and they were 4 of them that were sick recovered. So that was back in the 50s, and veterinarians have been doing this for quite some time, but no one really took it seriously or thought about it. And then it sort of cropped up. There was a few doctors doing it, and then it cropped up in the internet. And this is, in the book, I focus on this grandma from, I think it was Ohio. Her name was Catherine Duff. And she was in the late stages of a C. diff infection. Nothing was working. She was literally dying. And there was tens of thousands of people doing it online at that point. You could just download a YouTube on how to do a fecal transplant. So her husband provided the feces, and she did it, and she literally felt better that day. And so she was just impassioned to get this message out. And at that time, the NIH knew about this, there was a clinical trial going on, and they were comparing people with C. diff. They'd give them a fecal transplant or antibiotics. In the trial, the people getting the fecal transplant, 94% were cured. The 6% that weren't, you just did it again, they were cured. And the antibiotic group at that point only showed a third were getting better. So they immediately stopped the trial and gave all the other people, the crossover. They gave them the fecal transplant. So the NIH had that data, and they were having a meeting about what to do with the fecal transplant. And it just got lost into this huge, well, we don't know how to regulate it. There could be problems. There's this vague idea that if you took the feces from an obese person, maybe they might gain weight 10 years later from their from their microbiome. And so they were going to put it under an IRB, investigational review boards, and an IND status, investigational drug. So anytime a doctor did it, they have to go through this 3-inch thick of paperwork to even do it. So nobody would do it. It was effectively
you said it would take like a year or something, right?
Yeah, to do the IND status. So no one was going to do it. They effectively stopped it. So she stood up and spoke and was like, people are dying from this today, right now. And you guys are going to mire these doctors in paperwork. They're not going to be able to get this. No one cares if they gain weight 10 years from now. They can sort that out later. They're going to die in a few days. And so she sort of, added back in this rationality of a real patient dealing with the problem. And then they did change so they could get by, doctors could do it without risk of liability at that point. But this took so long, and everybody knew it was a cure, but no doctor wanted to be the first one mixing poop in a blender in the office, and there's a myriad of reasons why they didn't do it. But now it's pretty much standard of care. They do it all. There's poop banks where if they're super healthy, you can donate your poop and get paid.
Wow.
But it took forever for that to happen.
Wow. No, that's amazing. And I think, as we were talking about at the beginning of the show, like, you combining the biology and the science with the story was so fascinating. Picturing that room where this one person, she's the only person that's not involved with the FDA or something. And she gets up and makes this like impassioned speech on day 2 of 2 and gets a standing ovation and revives the talk about it. What a crazy cool story.
Yeah. It is. That was an amazing story, and I kind of remember the evolution of it. I remember when my local hospital here was just they were one of the first ones to kind of adopt it and say, this is legit. We need to start doing this. And I don't know if they make the pills, because now you can either take a pill or do the enema, but they were one of the first ones to do it. But the adoption rate was just painfully slow. So people literally would just go to do it yourself on YouTube and learn how to do it. And literally tens of thousands of people were doing it a year on their own.
Wow. And seeing those amazing results like that day or the next day or whatever, just super quick.
Yeah, it's crazy, isn't it? I mean, think about it. It's just an ecosystem. So you have this one pathological you take antibiotics, you wipe out the ecosystem. This one pathological bug takes hold. And usually you have all those bugs in there that keep everything in check. And most people have some C. diff, but it's kept in check by that microbiome. So it just makes absolute, that's why vets were doing it, because they just have that horse sense. Well, yeah, you just put the ecosystem back in there. And, so intuitively, it's incredibly simple, but it just took forever to get it adopted.
Sure. I think learning about the process of fermentation with, brewing beer or making, sauerkraut or kimchi, you realize that one form of bacteria eats the other one, that eats the other one, that eats the other one, and on down the line until you get the one that, like, wow, this gives it that flavor that you really love. And that the same thing is happening in us all the time. It's so interesting. I love that.
Yeah. The microbiome's like the undiscovered country in medicine right now. There's so much to learn, even like a ketogenic diet, was standard of care for epilepsy for a long time. But nobody knew quite how it worked. The ketones were doing something strange in the brain, but we just knew it worked, right? So in the 1920s, it was standard of care. And they did an experiment fairly recently where they put mice on a ketogenic diet, and they had epileptic mice. They transferred the gut biome of the mice on the ketogenic diet into the epileptic mice, and it stopped their seizures.
Wow.
So the mechanism of action, lots of mechanisms of action go back to the microbiome. It was just so underappreciated what was going on in there.
It's amazing. Another thing that in 5 or 10 years, if we talk again, hopefully we've learned so much from that and really pushed the ball forward there. I love in the book also how you talk about success stories. And one of them is in my backyard, which is great. Can you tell us a little bit about Intermountain and what things they're doing right that might be different from other systems?
Yeah. Intermountain's an amazing story. So Brent James there, he's a guy, a really transformational guy. And they looked at this problem of over-treatment and variation in treatment. And he knew it was a massive problem. So how do you tackle it? What he would do is he'd look at their electronic medical record system and he would see the massive variation in treatment for certain things, right? And when he could see that variation in treatment, he knew there was a problem. He's like, we got to narrow this down to the best practice. What is the best way to do this? So one example is giving antibiotics before surgery. So doctors will do that to prevent surgical infections. No one knew the best time to do it. So he'd look at the EMR. Some doctors were giving it 2 hours post-surgery. Some were giving it 2 hours before surgery. Some right at the time of surgery. So he had doctors, he put them into groups and had them, do it at those various times. Then they just tracked the infection rate. And they learned, I think it was something like an hour before surgery or something like that was the optimal time to do it. So he established the best practice from this huge uncertain cloud, this variation in treatment. And he would just look one thing after the other, he would check off the list and do that same process. And, the totality of that in the end, when you look at Intermountain, there's a 40% reduction in cost. So if you applied that same system, it would solve the healthcare crisis across the US. Not only that, their outcomes are so much better than the rest of the country. Heart disease, everything they do pretty much is better. So he's just a shining example of how, you can approach this problem. He gets pushback from the doctors. It can be a terrifying place to work. You feel like people are looking at you all the time and judging what you're doing. But at the same time, again, he's establishing those guardrails where now you know what to do, what the best thing to do is, and you can, within those guardrails, use your intuition. So it's a beautiful model.
Why could that not be repeated in every hospital system? Is there something preventing that from happening?
Well, I think it was Obama. He used that example in a speech about healthcare, which healthcare terrified him. It was the number one problem that was going to bankrupt the U.S. by far. Everyone talks about Social Security, everything, but healthcare is by far the worst. And he used Intermountain as an example of how we could do it better. But they're also disjointed and fragmented in the U.S. We don't even use the same medical record systems throughout the U.S. So getting that, having one adopted system is really difficult within our framework because it's just so disconnected.
Wow, that's so interesting. Okay, so I have a series of questions about what can be done about this. And first of all, I want to know, for like a schmuck like me, like I don't use the medical system. I'm not on prescriptions. If I go to the hospital, it's because I hit a rock on my mountain bike and endoed and broke my collarbone again or something like that. You know what that's all about. How should I be thinking about the issues and how can I help be part of the solution? What things can that type of a person do?
Yeah. Well, I approached that in the book. I looked at the sort of institutional problem and how we solve it. And then I looked at like individuals, what matters the most for an individual for staying healthy. And it's interesting because you start with the idea, well, you can't do much about genetics. We know that if you're predisposed to a genetic disease, you're most likely going to get it or have a higher probability. But when you look at identical twin studies, it's a perfect proxy to measure that. So you look, they're genetic clones. So you watch them throughout their lives. They rarely die of the same disease. So if you get a disease with 100% what we call coordinates, which means it's 100% genetic, which is very rare, both identical twins will get it. So like Huntington's disease is an example. Most of the other diseases have a discordance rate, like schizophrenia, I think is 50%. So if one twin gets it, the other twin has a 50% chance of getting it. And then you go down from there. Cancer, most diseases are not genetic. There's a genetic component, but it's mostly nurture. And what is nurture? Well, nurture is all the lifestyle decisions you're making every day, what you eat, how often do you exercise. And now, how do you measure, well, what nurture variables are the most important? And there's a great study by Julianne Lundstedt Holt, where she just looked at 4 million people very different lifestyles. So she measured all the big things like smoking, exercise, diet, and she measured how much those variables matter in you developing a disease or you staying healthy. What she found was the number one and number two were your social life. So the number one variable in how long you'll stay healthy is very close connection. So family, friends, people you can count on in a crisis. Number two is social integration. So how many people do you encounter throughout the day? Do you chat with people at work? Do you go on a mountain bike ride with your buddies? Do you have a book group or whatever? Those two far and away outstripped anything. If you were low in one of those, it was equivalent of smoking 15 cigarettes a day, right? So that, and then why does that matter? So you look at the 22,000 genes, and people that report being very lonely, about 200 of them are very differently expressed, and they all relate to the immune system. So you get a really ramp up in this early acceleration phase of the immune system. So in other words, they're chronically inflamed. And you get a downregulation in the targeted adaptive immune response. So your ability to fight off viruses and infections is reduced. So your immune system is always kind of low grade, turned on, and then turned off when you really need it. So that's how that biological sort of feedback loop manifests in the body. But how you approach that is up to you. How, are you lonely? You need to get out there? What do you need to do to make it so you do not feel lonely? And again, that is not a fixed number for most people. It's just, do you feel lonely or not? Some people are introverted and they don't need a lot of connections to feel not lonely. So, but that, and then I looked at the person, all these people, the super centenarians. It's 1 in 7 million people will live to be 110 or above. And they have no idea why. They have very different lifestyles, but the one commonality is social connections throughout all those people. And I looked at the French lady who has the longest lifespan ever recorded. She lived to be 122. And, according to most people, she probably did a lot of things wrong. She started smoking when she was 21. She stopped when she was 117, but she did not smoke excessively. She only had 1 or 2 cigarettes after dinner. She drank some port wine. She ate some chocolate. But what she did do is she had an incredibly unstressed life where she did tons of stuff outdoors, played tennis, went hiking, never felt, her friends said she never seemed stressed at all. She always seemed happy. She rode her bike around her village when she turned 100 and said thank you to everybody that wished her happy birthday. So the point to that to me was, you don't need to worry too much, right? Again, back to the body's an incredible resilient machine. And in fact, worrying about it too much may be more detrimental than having a cigarette after dinner, for example. I would never promote that, but I think, you get the point. So yeah, it's not a simple equation where do this, eat this, and do that. It's really more nuanced. It's more artful than that. You just need to live a life that, your grandma told you to do. Get outside, play with your friends, eat whole foods, that kind of thing.
Yeah, what a beautiful message. And we sit here and try to calculate how many grams of protein you should be eating, what your fasting window should be. It's like, we should all just probably chill out a bit. And I absolutely love that message. That's great. Another question would be for somebody who is entrenched in the medical system. They're going through, for example, cancer treatment. Do they need to start doing their own research and start pressing their doctors on different options the way that Martha Tettenborn did? Like, what would you say to that person?
Absolutely. Yeah. And the studies show that, people that are more proactive. I talked to a doctor who, he told me that he was a biostatistician at City of Hope. And he told me that he looked at the data, I think it was bladder cancer, the mortality data on just a small regional hospital. And then one of the major cancer centers where people will go to get clinical trials or just, seek out because they perceive to have better treatment. They were giving the same treatments, the exact same standard of care at both places, but the mortality rates for the cancer center, the higher quality one, were way, way better. It almost looked like 2 different diseases, he said. And the question then is why? And it's those people were seeking out the best, right? They were just motivated to live more. And so it was just a difference, and it was a healthy user bias. You just have a vastly different motivation, a different patient group. So that in itself can be healthcare, just being proactive and not feeling helpless. So yeah, you do want to seek those things out as much as you can, get as much information as you can. And back to the lifestyle thing, there was a breast cancer study 3,000 women with breast cancer. The ones that reported to be lonely versus the ones that had a very robust social network were 4 times more likely to die from the disease. So that's a very intangible thing, just seeking support. And it goes back to when you are stressed like that, stress can be very caustic, but your body can handle stress. But the way it does that is it releases endorphins. And those endorphins are prompting you to seek out help. So if you heed that seeking out the help, it makes you more empathetic. So you'll listen to other people's problems too, but you'll also, seek out that social network. If you prompt that signal, stress has zero caustic. It does not affect your health at all. If you don't, it has a very profound effect.
Wow.
So your body's sort of giving you cues, on what to do in those situations as well.
Wow, so interesting. On that note, my mom was diagnosed with cancer in the late 90s. We switched our diet. We did everything low fat, so super high carbohydrate, worst diet in hindsight, but she still made it 7.5 years. And a lot of treatments, a lot of chemo come and go, but she didn't make it that long. And I think a huge part of that was her religious beliefs and her involvement in that religion that not only gave her faith, but it gave her something to do and something to wake up for. And she was in charge of certain activities. And I think of that when you say the social, networking as being something that's so beneficial that probably offset a really terrible diet in some degree, I would think.
Well, yeah, think about it. Cancer is provoked by inflammation. And if you go back to that, so she's waking up and you're right, she's got a reason to get up. She's going to church. She's seeing these people. And it feeds back into that epigenetic mechanism of the immune system where you wouldn't have that much probability as having that low-grade chronic inflammation. And those cytokines that promote inflammation feed cancer. They're powerfully growth-promoting factors. So it all makes sense biologically, right? We just didn't appreciate that like we used to now, that we know now.
Fascinating. Yeah. Last question for you. Magic wand, you're king for a day. Systemically, how does the system change?
Oh, man. In an ideal world, we go towards there's no going back from the data, right? The revolution in data. And machine learning and artificial intelligence is making such inroads into every industry, more than people, I think, realize, especially into medicine. It's it can diagnose, it can read radiological films better than humans now. I mean, vastly better. So kids aren't going into radiology and medicine anymore because they see the writing on the wall. This is slowly changing, and I think it'll get better slowly. The question, there's a great example of chess where machines can beat humans in chess right now, but the best way to play chess is have a coupled with a human where the human knows the artificial intelligence program it's playing with. It's called advanced chess. So they have people play with their program against other people with their program. That is better than the machine alone. So when you can add in the human intuition at the right time, you get the best outcome. So I think going towards that model of Intermountain where you encourage intuition, but you have those guardrails is where we have to arrive.
It's not one at the expense of the other. Both can be there and both can be helpful tools when needed.
That's the point. Yeah. And that's what the advanced chess has shown us, that the human component can be magical. It just can pick up subtleties that, in the subconscious that we don't even really know that's happening. And that's what you want from your doctor, is that kind of intuition that comes from decades and decades of practice, but confined within the data where it can guide us, in the best practices.
Wow, so interesting. This has been such an interesting conversation. I really, really thoroughly enjoyed talking to you. If you wouldn't mind, tell the listener where they can go to find you and connect with you and your work.
Yeah, well, go to Twitter. I'm on Twitter, and direct message me or anything. I don't post very much, but I'm on there. My work, we have the foundation. That's fun. We got incredibly philanthropic people donating a lot. So we're trying to kick off that ketogenic trial at Cedars-Sinai. So if anyone wants to help with that, it's a grassroots effort. I don't think it'll be done by the medical system. It's got to be done by the people. So we're close. There's a small funding gap. We're close to getting that filled. And then it's a phase 2 trial, be the largest trial ever in cancer in the ketogenic diet. Yeah, I can't wait for that to happen.
That's amazing. It's so encouraging to hear that you are optimistic about the future and that things may be slow, but they can change. And again, the one takeaway being, if all of us can just, for how serious and important this is, all of us can chill out a little bit more, slow our lives down a little bit more, appreciate the things that are around us, and maybe get a little bit less involved in the news cycle and more involved in, your neighborhood, your birds, social life, all that kind of thing, I think is a wonderful, wonderful message. So thank you, Travis Christofferson, so very much for all of your work. Thank you for going out and discovering what could have been many, many books and condensing it down into one book. And thank you for taking the time to be on our show today. We really appreciate it.
Oh, appreciate it. Thanks for having me, Casey.
Absolutely. Such an honor. And this has been another episode of Boundless Body Radio.